So, welcome back to class. So, we are still working on logarithm and we are looking at the topic change of base. Change of base is a logarithm law or rule which implies that we can change the basis of a logarithm figure, and there are some things that happens when we change the basis. So that's what we'll be looking at today. Now, how do we change the basis? For example, if I have log m base n, I can change this base n. But if I want to do that, I will be introducing an entirely new base. An entirely new base. So the numbers you have as m and n, you will determine the entirely new base you want to use to replace n. So, but let's say I'm using base x. I'm using base x. So I will write log base x in the numerator, and then we have log base x in the denominator. So I've written the two bases I'm using now instead of the previous base, which is n. Now, m here is the argument. The argument will become the numerator of the new base, while the previous base, which is n, will become the denominator. So in this case, I've changed base. I've changed base. So this is how we can change base of two numbers. So for example, let me look as an example. If I have log 32 base 8, now I can change base here. I said initially that the best I should do is to look for a, a base that has a relationship with the already existing numbers. So in this case, we have 32 and 8. So the best way for me to change the base is to find a number that has relationship with 32 and 8, most especially power relationship. So the number that should come to mind that has a power relationship with 32 and 8 is 2. So if I entirely change the base to 2, and we have log base 2 divided by log base 2. So I've changed the base. Like I said initially, the argument will become the logarithm in the numerator, while the old base will become the logarithm in the denominator. So I have this. Therefore, I can simplify further that log 32, 32 is the same thing as 2 raised to power 5 base 2, and 8 is the same thing as 2 raised to power 3 base 2. So from here, I can change coefficient, power to coefficient. So I have log 5 log 2 base 2 and 3 log 2 base 2. If you decide that this cancels out, you're correct. I have 5 over 3. And if you also see that when the base and the argument are the same, the answer is 1, we still end up with 5 over 3. So that is how we change base. Now let's look at this past question examples. This is a y question. So these are y questions. That's what we'll be looking at. So we have log 125, 125 base 0.20 by changing the base here. So I think I should first convert 0.20 to fraction. That will be 20 over 100. I'm multiplying the number. We're changing. Let me break this down so that we understand how we can change decimal to fraction. So 0.20 is the same thing as 0.20 over 1. So I will over 1, not over 10. I will look for a number that can change the 0.20 to whole number, full whole number. That will be 100. A multiple of 10, let's say a power of 10 that can change it to a number. Power of 10, I mean, numbers that could give power of 10 is 10 itself, 100, 1,000, 10,000, and so on. So which of them can change 0.20 to whole number without the decimal? That's 100. So I will use the 100 to multiply the numerator and the denominator. That's 0.20 times 100 divided by 1 times 100. That will be equal to 20 over 100. And 20 over 100 when divided to the simplest form is 1 over 5. So 0.2520 is 1 over 5. Or 0.2 is 1 over 5. So instead of the 0.20, we have 1 over 5 there. So I have log 125, then I have 1 over 5 here. So from there, I can change the base if I want to. But there are other logarithm ways we can use to solve the same question. But since we are doing change of base, we use change of base. So I would need a number that has a relationship with 1 over 5 and 125. Power relationship. And the best is 5 itself. So I will write log base 5 and another log base 5. The argument, which is 125, will be the numerator. The base, the previous base, will be our denominator. So I have 1 over 5. Let me write this better. 5. So from here, I can change 125 to a power of 5. That will be log 5 raised to the power of 3. 5 raised to the power of 3 base 5, all divided by log 1 over 5 expressed as in power with 5 raised to the power minus 1, then base 5. So if we make power to become coefficient, we have 3 log 5 base 5, all divided by minus 1 log 5 base 5. And when the base and the argument are the same, the answer is equal to 1. So in the two places over here and over here, the answer will be 1 because the base and the arguments are the same in the two places. So since they are the same, they are 1. So we have 3 over minus 1, which is equal to minus 3. So the answer is minus 3. So go on to take the second example. So we have log 0.3 base 4 minus log 0.48 base 4 plus log 0.05 base 4. So as we can see, I can apply first and second law to this, which says first and second law. Let me write them. Log, let me say I have x m times n will become log x m plus log base x n, and the second one log m over n base x will be log m base x minus log n base x. So from here, since I have negative and positive in between, I'm simplifying in this pattern from the right to the left. The same thing for this, from the right to the left. That is, where I have subtraction, it will change to division. Where I have addition, will change to multiplication. So since they all take the same base, which is base 4, so log base 4 of 0.3 0.3 minus log base 4 of 0.48 plus log base 4 of 0.05. So from here, let's see what we can do. We write a single base 4. So I'll open a bracket. This will divide it, since there are subtraction in between, that will be 0.3 over 0.48. Then since there is addition here, this will be times 0.05, which can be better written as log base 4 in brackets 0.3 times 0.05 all divided by 0.48. So we use our calculator at this point. Use the fraction mode of the calculator. 0.3 times 0.05, then the denominator of 0.48. So 1 over 32. So I have log 4 1 over 32. And 1 over 32 is the same thing as 32 raised to the power minus 1. So log 4 32 to the power of minus 1. Now, I can apply change of base. So, if I apply change of base, I'll be introducing an entirely new base that has a connection with 32 and 4. And that should be 2. So I have log 2 in the numerator. Now also have log 2 in the denominator. So the argument will become the one at the numerator, while the base, the previous base, will become the one at the denominator. So from here, I can take power to coefficient. So I have, or express both as power. So we have log 2. 32 expressed as a power of 2 will be 2 raised to the power of 5. And don't forget we have minus 1 there before. So I put the minus 1 here. So this is what we have in the bracket is 32 before the power minus 1. Then for the denominator, I have log 2, 4. 4 is the same thing as 2 raised to power 2. So we have 2 to the power of 2. So this is the same as log 2 raised to power minus 5. By the time the power in the bracket multiplies the power outside the bracket, I have 2 raised to power minus 5 base 2, all divided by log 2 raised to power 2 base 2. So from here, power turns to coefficient. So we have minus 5 log 2 base 2 divided by 2 log 2 base 2. So whichever way, this is 1. The numerator and the denominator, I mean log 2 base 2 argument and base are the same. So they are both equal to 1. So, and as well, you can decide to divide both of them since they are the same. So one side is minus 5 over 2. It can also be written as minus 2.5 or minus 2.5. So all these are specifically the correct answer. So if we take the last last example on this is a giant question. So we are using log 2 to replace x. We are using x to replace log 2. We are using y to replace log 3. We're writing our answer in terms of x and y. For the question, log square root of 1 over 72 base 27. So let me write 1 over 72 in a better way. Square root, I can write it. Okay, we have a lot of simplification to do here. So we start with 1 over 72, square root of 1 over 72. So I can write that as square root of 72 raised to the power minus 1 from one of the laws of indices. Now when we have 1 over an x, okay, don't let me say 1 over. If I have x over y raised to power n, I can write it as y over x, then the power will get a negative. So the power for 72 here is 1. So if I turn it is 1, not. Okay. The power for 72 is 1. So if I turn it upside down, change denominator to numerator and numerator to denominator, I have 72 over 1 to the power of minus 1, which is the same thing as 72 raised to the power minus 1. So that's what I did. So when you turn a fraction, it gets a negative power. So I now have square root of 72 raised to the power negative 1. Then if I am applying fractional power law, I said the denominator of the fraction becomes the root. So since we have a root here, which is square root, so it will become a fractional figure. That's 1 over 2. So we have 72 raised to the power minus 1 72 to the power of minus 1 raised to the power 1 over 2. So that is 72 to the power of minus 1 over 2. So that is square root of 72. So instead of that square root of 72, I'll write that 72 to the power of minus 1 over 2. Then we have base 27. So let's apply the change of base from here. Let's apply the change of base from here. So I will be introducing an entirely new base. Entirely new. I'm thinking which base should I use? Let's use base 10. Why am I using base 10? Because we have log 2 as log and log 3 as the value we are replacing. Log 2 and log 3. Log 2 and log 3. And I have said when no base is written, then the natural base of base 10. So that's why I'm using 10 here. So that whatever I'm replacing, I can easily replace it. If I use another base, It will create a problem because I won't be able to replace if I have another base. So we have log base 10, log base 10. The arguments will become the numerator, while the old base will become the denominator. So from here, I can simplify further. Firstly, the power turns to coefficients. Then log 27 base 10. Now from here, 72 is we can replace 72 with 2 raised to power 3 times 3 raised to power 2, the prime factor of 72, which will be correct based on what we have here. Then all divided by 27 is 3 to the power of 3. So I will simplify this way, use first law, and we have log 2 raised to power 3 plus log 3 raised to power 2, all divided by log 3 raised to power 3. Don't forget they are all in base 10. And if I decide not to write the base again, they are still in base 10. When no base is written, they are in their natural base 10. So from here, I can change power to coefficient. So I have 1 over 2 in brackets, 3 log 2 plus 2 log 3, all divided by log 3 log 3. So I can use the power, I can open up the brackets in the numerator. So we have it will be multiplying the coefficients alone, not everything. So we have 3 over 2 log 2 plus 2 over 2 log 3, all divided by 3 log 3. So that's 3 over 2 log 2 plus 2, they will divide 2 here, then we have log 3, all divided by 3 log 3. So log 2 will be replaced by x and log 3 will be replaced by y. So from there, we have 3 over 2. Let's look at it from here. So instead of the log 2, I will have x. Then instead of the log 3, I will have y, all divided by 3y. So if I take the LCM of the numerator, I have 1. Take the LCM of the numerator, that will be 2. So solve it as addition of fraction. I will have 3x plus 2y. Then if I turn what I have here to division, it's dividing, so over 3y. And from there I turn it to multiplication, I will have 3x plus 2y over 2 times, so it's 3 over 1 here. 3y is the same thing as 3y over 1. So I have 1 over 3y. Therefore, my answer will be 3x plus 2y, all divided by 6y. And that is the answer. So if you present your answer, like the first one we got in this, yeah, still absolutely correct. But in a better simplified form, we have this. So thanks for staying tuned. That is change of base and logarithm. Like, comment, and share. And if you have any need for an online mathematics teacher, I will be available. Thank you.